Okay, so today we are going to focus on multiplying special products and multiplying polynomials bigger than a binomial times a binomial. For example, a binomial times a trinomial or a trinomial times a trinomial. All right, so let's start out with this first example here. It says the square of a sum, and it gives you this formula that probably makes you want to jump out of your skin. Don't stress about that. The reason for the formula is so that you understand that a plus b quantity squared is not just a squared plus b squared. If we actually work this out, we get a squared plus 2ab plus b squared. So let me show you why. If I have a plus b quantity squared, think about what it means to square something. It means to multiply it by itself. For a second. That really means to say a plus b times a plus b. So if I then use one of the methods that we learned yesterday for multiplying a binomial times a binomial, so let's say I use the FOIL method, that would give us a times a, which is a squared, and then for our outsides, a times b is plus ab. For our insides, b times a is also ab. I'm going to write it alphabetical and not write ba so that I don't get confused. And then last but not least, b times b for our last would give us plus b squared. And then we can see right here in the middle we have these two like terms. We have an ab and an ab, so that's 1ab plus 1ab. So when we combine like terms, we get a squared plus 2ab plus b squared. What happens is students will see this a plus b quantity squared and they try to apply their exponent rules and they think, oh, all I have to do is just distribute the power. That's a squared plus b squared. And that is wrong. If you distribute the square, you only do two multiplications. And when we multiply a binomial times a binomial, there's 4 multiplications that have to take place. So all those exponent rules that we learned at the beginning of Unit 4 were for only monomials. Those rules are if you have a product raised to a power or a quotient raised to a power, you can distribute the power. You cannot do that if you have a sum or difference raised to a power. So pretty much all you have to know is anytime you see a binomial squared, write it out twice, and then multiply your two binomials together, either using the box method, the distributive method, or the FOIL method. So starting out with this first one, because I have that binomial squared, I immediately realize that that is just saying to do 3a plus 2 times 3a plus 2. Sometimes what I do just to make it quicker is I just scratch out that square right there and then write my binomial again beside it, because that's really what that is saying to do. So let's say I use the box method in this case. So I draw my box, and on one side I'm going to put 3a and positive 2, and on the other side 3a and positive 2. So when I multiply my windows together, 3a times 3a is 9a squared. 3a times 2 is 6a. 2 times 3a is 6a, and 2 times 2 is 4. We can see that we have these like terms right here, 6a plus 6a. So when we write our final answer, that would be 9a squared. 6a plus 6a is 12a plus 4. Some special properties you'll notice about the square of a sum is the first term always comes out to be a perfect square because you multiply the same terms together. And the last term always comes out to be a perfect square because you multiply the same terms together. So looking at the formula, that's why it's a squared in the front and b squared in the back. And then because you get the exact same terms for your middle terms, or like when you FOIL your outer and inner terms, that's why it's 2ab. So it's like if you multiply a times b and you get it twice. So if you like the formula and you understand the formula, you can use it. Most students don't really start to do that until they've done these for a long, long time, probably normally by like later Math 2 or Math 3. Most of the time at this level, all we're going to do is just write it twice and practice our FOIL or box method or distributive method. All right, pause the video, try the next one. Okay, so this time I'm going to FOIL. I will suggest don't keep changing up your method. Either do the box method or do the FOIL method so that you get that method down pat. It's confusing to change it up. I'm only changing it up so that depending on which method you like, you can see it done that way from time to time. All right, so first times first. 5b times 5b would give us 25b squared. For our outside terms, That would be 5b times 7c. So 5 times 7 is 35, and then b times c, we would just write bc. For our inside terms, that would be 7c times 5b, so 7 times 5 is 35, and then c times b, we're going to write alphabetical bc. And then for last times last, 7c times 7c is going to give us positive 49c squared. Make sure you do the 7 times 7 and the c times c. Again, we have those like terms there in the middle, so our final product would be 25b squared. 35bc plus 35bc is 70bc, and then plus 49c squared. All right, the next set of problems is the same. The only difference is it's the square of a difference. You do the exact same thing. You're going to write it twice and box, FOIL, or distribute. The only difference is if you look at the actual formula or pattern, the middle term this time will be negative. So let's just work one out and see how that works out. So starting with this first one, I have x minus 13 squared. Because it is a binomial squared, I'm going to scratch out that square and write it twice, and then box, FOIL, or distribute. In case I have a few of you distributors out there, I'll distribute this one. So I would say x times x minus 13. I'm doing this x right here times our binomial, and then negative 13 times our binomial of x minus 13. So then x times x is x squared. X times negative 13 is negative 13x. Negative 13 times x is negative 13x. And negative 13 times negative 13 is positive 169. So we would then combine like terms. X squared minus 26x plus 169. So you can see, like the first two we did, the first term and the last term are perfect squares. And the middle terms are the same terms, but they're both negative in this case, so that's why it has the minus in the middle instead of the plus. All right, pause the video, try the next one, and check it out. All right, so I'm going to use the box method this time. 6a times 6a would give us 36a squared. 6a times negative 7 is negative 42a. Negative 7 times 6a is negative 42a. And then negative 7 times negative 7 is positive 49. Make sure you pay attention to your signs right there. So when we pull that out and put it together, that is 36a squared. Negative 42 and negative 42 gives us negative 84a plus 49. And it has that trinomial pattern. All right, last but not least, a difference of squares. This one is really important. And when we get into factoring, next week it's going to be huge when we start to factor binomials. So what happens here is, what happens when we multiply two binomials together that look exactly the same, except one has a plus in the middle and one has a minus in the middle? This is the only time when you multiply two binomials that your final product, your final answer, will also be a binomial. So let me show you why. Let's say we use the FOIL method on the first one. 6x times 6x, first times first. That would give us 36x squared. All right, then for our outside, 6x times positive 7y. That would give us positive 42xy. Then when we do our insides, negative 7y times positive 6x. So a negative times a positive is going to give us a negative. 7 times 6 is 42. Y times x, we're going to write alphabetically, xy. And then last, negative 7y times positive 7y is going to give us negative 49, because positive 7 times negative 7. And then y times y is going to give us y squared. So in this case, just like the last two, we also have like terms. But our like terms are exactly the same, except one's positive and one's negative, so they're going to cancel. And that's why our final product ends up being just a binomial and not a trinomial like the first four problems. So we get 36x squared minus 49y squared. And we call this very special product a difference of squares because that's exactly what it is. You have a perfect square minus a perfect square, so it's called a difference of squares. All right, pause the video and try the next one. All right, so using the box method this time, 14m times 14m is 196m squared. Positive 14m times negative 9n, 14 times negative 9 is negative 126, and then m times n is mn. Positive 9n times positive 14m is going to be positive 126mn. And then right here in our last little corner, positive 9n times negative 9n is going to be negative 81n squared. So again, you can see right here, we do have like terms, but they're exactly the same. One's positive and one's negative, so they cancel. So our final answer is 196m squared minus 81n squared. All right, so really, guys, these problems, these last two right here, is the same thing we were doing yesterday. You're just multiplying a binomial times a binomial. So whether you recognize that they're exactly the same except one's plus and one's minus or not, you should still know to FOIL, box, or distribute where you multiply 4 times. However, anytime you see a binomial squared, you've got to know to write that binomial twice and then multiply them. Never ever distribute that square or you're going to get the wrong answer every single time. All right, last part of our lesson, how do we multiply polynomials that are bigger than just a monomial times a polynomial or binomial times a binomial? There are 2 ways that you can do this. You can do this using the distributive method, or you can do this using the box method. You cannot do this using FOIL. FOIL is special for only binomials times binomials. Anytime it gets bigger than binomials, you can't use FOIL because there's only 4 letters in FOIL. I honestly believe that the box method is the easiest way. So when I look at this problem right here, I have a trinomial because it has 3 terms by a binomial because it has 2 terms. So what I'm going to do is I'm going to come over here and I'm going to draw a box that either has 2 rows and 3 columns or 3 rows and 2 columns. It really does not matter. Whatever side sits in my box in this case, I'm going to have 2 rows and 3 columns. So the side that has 2 spots, I'm going to put my binomial. So I'm going to put my k and my positive 3. And then along the top where I have my 3 slots, I'll put my trinomial. So that's going to give us k squared, 3k, and then 9. And then you do the exact same thing that you did when multiplying binomials. All you had to do was just make the box bigger. So when we go through and we multiply this out, k times k squared is going to give us k cubed. K times 3k is 3k squared. So I'm just using my exponent rules now. K times 9 is 9k. And then when I come down here, 3 times k squared is 3k squared. 3 times 3k is 9k. And 3 times 9 is 27. And luckily, if we look diagonally right here, we've got our like terms. We've got our k squareds right here and our k's right here. So to write our final product, we're going to say this is k to the 3rd power. 3k squared plus 3k squared is 6k squared. 9k plus 9k is 18k. And then last but not least, we'll put our constant term plus 27, and you're done. Technically, you could also do this by distributing. You could have written it out like this. You could have said, okay, I've got k squared times k plus 3 plus 3k times k plus 3 plus 9 times k plus 3. And then distribute it, and you'd end up with 6 terms and then combine like terms. But I'll be really honest with you, the box method is a lot easier, and then the terms are kind of lined up, and it makes it a lot quicker, a lot less mistakes. All right, so pause the video, try the next one, and then check your answer. All right, so in this case, we have a binomial, 2 terms, by a trinomial, 3 terms. So I made a 2 by 3 box. I want you to also understand, let's say you had a trinomial times a trinomial. You would just make the box bigger. Then you would make a 3 by 3 box, and so on and so on. All right, so if we do our box, you can see I've already multiplied my little windows. Again, my like terms end up being diagonal. And the reason why they do that is because when I made my box, I had my terms in descending order. So when we go to write our final product, it would be 2x cubed. Negative 24 and positive 10 is negative 14x squared. Negative 120 and negative 4 is negative 124x. and then last but not least, plus 48. If you really just cannot stand the box and you don't like doing it that way, let's say you do it the distributive way. I just want to go through this with you real quick and show you what I would do to maybe make it a little bit less complicated. So we distribute the x to the trinomial and then the negative 12 to the trinomial. You're going to see that you're going to get the exact same terms that we had in our box. So x times 2x squared is going to give us 2x cubed. X times 10x is going to give us 10x squared. X times negative 4 is negative 4x, just like you see in this first row over here in the box. Now when I go to do my second part, instead of writing it horizontally, what I'm going to do is try to bring it down and line it up with its like terms. So negative 12 times 2x squared is negative 24x squared. Negative 12 times 10x is negative 120x. Negative 12 times negative 4 is positive 48. This way, my like terms are all lined up, and all I have to do is add vertically. So we'd have 2x cubed minus 14x squared minus 124x plus 48. And that concludes our lesson for today. So you're going to have a little Delta math assignment to do. And then there will also be a review that you can do to help you get ready for the assessment on what we've learned this week for tomorrow. Good luck.